Okay? So again, so let's start. So this is Electrical Engineering Part 1. Okay? So yung pre-board exam nyo, diba? So July 29, 2022. Okay? So and okay. So this is EE July 2022, no? So again, note, diba? So parang yung sa mathematics lang natin, yung number 1 hanggang number 20 dyan sa pre-board nyo, or actually dun sa i-discuss natin ngayon, yung number 1 to number 20, so is lumabas noong April 2022. Diba? Okay, nakaba? So actually the rest ng mga nakolekta namin questions noong April 2022 lalabas sa face-to-face coaching. Okay? So kaya kung gusto niyo humabol pa doon sa face-to-face coaching, message lang kayo. No? Meron pang mga around 50 slots din sa tatlong natitirang schedule, yung Sched 1A, Sched 2A, saka yung Sched 3A. No? Okay, so anyway, so again, so let's start with number 1. So may copy na naman kayo, most likely. Diba? Okay. So pero again, so from time to time, papakita ko pa rin itong PDF na to. Okay. So again, the units of the electric fields are, of the electric field are blank. Okay. So again, so for number 1, okay, so lumabas na noong April 2022. Excuse me. Okay. So again, lumabas na noong April 2022. So again, unit of the electric field. Diba? What's the definition for the electric field? Okay, diba? So ang definition niyan is if we have a test charge, diba? Okay, so tapos nilagay natin yung test charge natin so near another point charge, diba? So then that test charge will experience a force, diba? Yung force na nararamdaman ng test charge natin, okay, per unit charge niya, okay? So then that is what we call the electric field. So ibig sabihin, so by definition, so this is a force per unit charge. Okay? Okay ba? And again, so what's the unit for force? That's Newton. Per unit charge, that's coulombs. Diba? So kaya this will be Newton per coulomb. Okay? Okay ba? So now, dun sa libro na pinagkunan namin itong tanong na to, diba? So meron dalawa dong tanong na what is the unit for electric field, diba? Yung isa, ang nakalagay sa choices ay joules per coulomb meter. Okay? Kasi baka isa dito yung baka aside from this biglang ito yung lumabas sa board exam, diba? So kaya mas maganda na alam niyo pareho. So again, so obvious naman to kasi joules per meter is Newton, diba? Okay? So again, so this should be letter B. Okay? So next number 2, no? So yung number 2 lumabas din April 2022, no? Okay? So yung tanong naman dito so is a total resistance of 3 ohms is to be produced by combining an unknown resistor R so with 12 ohm resistor. So what is the value of R and how is it connected to the 12 ohm resistor, diba? So okay, so one thing we need to note, diba? So is pag nag-connect tayo ng mga resistances in series, alam natin na yung total resistance natin lagi siyang mas malaki compared sa individual resistances. Okay? And pangalawa, if kinonect naman natin yung resistances in parallel, the total resistance is always less than the individual resistances. Okay? Nakuha ba? So this means, diba? So that, okay? Since yung total resistance daw natin is 3 ohms, diba? So as you can see here, so again, so we have 3 ohms. Okay? Okay? So again, as you can see here, so again, so this is 3 ohms, diba? And again, so this is to be produced, diba? So by using an unknown resistor R saka 12 ohm. Pero again, so makikita natin dito na yung total resistance natin na to mas maliit dun sa 12 ohm resistor. Okay? Okay ba? So ibig sabihin, so again, so since we know so that, okay, so since, okay, so 3 ohm, so this the total resistance is less than 12 ohm. Diba? So alam natin na yung R saka yung 12 ohm resistor natin, so are connected in parallel. Okay? Tama ba? Pag ginawa nyo itong series, negative yung makukuha nyo resistance. Diba? So kaya pag series yung ginawa nyo assumption, babalik din kayo sa parallel. So but again, you can analyze it this way. Diba? So therefore, so we can use, diba? So dito sa pag mga gantong tanong, diba? given tayo ng total resistance, di ba? Hinahanap yung individual resistance natin. Okay, so I use this equation. Di ba? So kasi mas madali itong gamitin compared dun sa R1, R2 over R1 plus R2. Okay? So although pwede naman kayo mag-shift solve. Di ba? So yung yung advantage na kasi pag ito yung ginamit nyo sa S, pwede kayong pwede nyo gamitin yung reciprocal button sa calculator. No? So, pakita ko sa inyo later. So, okay, so this will be 1 over 3 ohm. Okay, so 1 over 3 ohm is equal to, this is the unknown resistor R, diba? So then we have 12 ohms. So 1 over 12 ohm. So then we can solve for the resistance R. Okay, okay ba? So now, so let me just open. So ito yung reciprocal button na sinasabi ko sa calculator, di ba? So kaya dito, so for example, we have 3 ohm, di ba? So reciprocal minus 12 ohm, reciprocal, so that equals reciprocal, di ba? Okay? So kaya mas mabilis yung i-solve, di ba? So sa calculator. Okay? So kaya, usually pag parallel, yan yung ginagamit ko. Especially pagdating sa alternating current, kasi complex na, di ba? So kaya, mas mabilis siyang gamitin compared sa R1, R2 over R1 plus R2. Pero again, so nasa preference nyo naman yun. Di ba? So this is 4 ohms. And again, so as we deduced earlier, di ba? So this should be parallel. Okay? So yung sagot natin dito is letter A. So 4 ohm parallel. No? Okay? So next problem number 3. Okay? So for number 3, so we have 4 ohm resistor. Okay? So we have 420 ohm resistor. So equal resistances lang to. So kaya ang gagawin ko muna doon sa solution natin is ililet ko muna to as R. Okay, so gagawin ko muna tong R. No? So they are connected in series. Diba? So the combination is connected to a 20 volt EMF device. So tawagin muna natin to as the voltage V. Okay? So the potential difference across any one of the resistors is blank. So then tawagin natin itong potential difference na to across any one of the resistor as V sub R. Okay. So okay, so tawagin natin to as V sub R. Okay. Okay. So then, so let's try that. Okay, so we have, sa akin meron daw tayong 4, diba? So na resistor. Okay. So then sa akin tawagin muna natin to as R, 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 diba? Okay. So and again, so let's say that the voltage across them is V. Okay. So and the voltage across any of the resistors, so again, this is positive and negative. Okay. So the voltage across any of the resistors are VR, diba? So again, so alam natin na dapat equal tong voltages na to, diba? So kasi equal yung resistances. Kasi remember that the voltage is equal to current times the resistance. And since they are connected in series, yung current na dadaan sa lahat ng resistor natin, yung current I lang, diba? So kaya ibig sabihin, diba? So yung VR natin should be the same. So therefore, we can apply voltage division here, right? So again, this is the resistance across yung sinosolve natin voltage. For example, pag ito yung sinosolve natin, so then that's the resistance R. Pag ito yung sinosolve natin, that's the resistance R. So kaya regardless kung anong voltage yung isolve natin, R lang yung nasa numerator, divided by yung sum ng lahat ng resistance natin. So R plus R plus R plus R, in this case that is 4R, diba? So then multiply this by the total voltage V. So then this is just 1/4 of the voltage. Kaya from the given, again, that's 20 volts divided by 4. So kaya this is equal to 5 volts. Kaya actually this is regardless of the resistance. Kahit anong value ng resistance natin, basta equal sila, 4 sila na kinonect mo dun sa voltage source. So then yung voltage kada resistor natin, so should be 1/4 of the total voltage. Okay? So this is letter B. Okay? Tama ba? So again, so that's problem number 3. So again, lumabas din to April 2022. No. Okay? So number 4, so ito lumabas din April 2022. Okay? Okay? So for this one, Okay, suppose this page is perpendicular to a uniform magnetic field and the magnetic flux through it is 5 Webers. Okay, nakuha ba? So ito yung gagamitin natin as our first case, yung page natin, so or yung loop, di ba? So or yung area is perpendicular dun sa uniform magnetic field natin. Okay, nakuha ba? So and given sa ating magnetic flux. Okay, remember magnetic flux is yung phi. Okay? So if the page is turned 30 degrees around an edge, di ba? So then the flux through it will be black. So again, pag sinabi natin around an edge, di ba? So again, so imagine so this is our page, di ba? Or this is our paper, okay? So then pag nagkaroon ka ng angle around an edge, di ba? So then sabihin, so ganito yung mangyayari dyan. So dito siya iikot, okay? Nakuha ba? So again, dito sa, with respect to this edge, okay? Nakuha ba? So ganyan yung gagawin natin, di ba? So again, so for the first case natin, so let's call this as our case 1, okay? Nakuha ba? So again, so this is the case when the page, so let's say ito yung page natin. Okay, so we have this page. Okay. So then, diba? So again, so meron ay subjected sa magnetic field. So again, so let's say this is our magnetic field, diba? And let's say the magnetic field is oriented, okay? So perpendicular dun sa area natin. So again, so these are perpendicular like this, okay? Okay ba? So again, so yan yung ito yung magnetic field density natin. So tawagin natin to as B, no? So and remember na pagdating sa area natin, diba? So I think nabanggit naman natin ito sa lecture, diba? Okay? So okay, so yung area natin, diba? So is yung direction ng area natin is in the direction such that it is perpendicular to the area, diba? So again, so yung direction ng area natin is the normal vector of the area, diba? So kaya let's see. So okay, siguro yung blue. Okay? So okay, so ibig sabihin sa let's say ito yung original direction natin. So again, so this will be the area A. Okay? Nakuha ba? So ay makikita natin dito na yung magnetic flux density B natin saka yung area A natin are in the same direction. Diba? And remember, what is the equation of the flux? Diba? Okay? So again, so if you remember, so again, so this is equal to magnetic flux density times the area. Diba? But again, that's just magnitude. Diba? So again, so remember that magnetic flux density so is a vector. And again, so the area can act as a vector, diba, in the direction of the normal vector, diba? So kaya ibig sabihin, so this should be a dot product or a cross product, okay? And if you're familiar with this, diba, so kaya kino-consider lang natin sa magnetic flux natin is yung magnetic flux density that's oriented perpendicular to the area. So hence, this should be a dot product, diba? So again, so we have B dot A, okay? Or in terms of magnitude, this should be BA cosine theta, diba? Kaya kung ang alam niyo lang, so na equation for the magnetic flux is B times A, magnetic flux density times the area. So again, so that's under the condition na yung magnetic flux density mo is perpendicular so dun sa area natin. Okay? Okay? So again, so this is our actual equation. And in this case, diba? So yung theta 1 natin, so again, so tawagin natin theta 1. So again, for the first case, this is 0 degree. So kasi nga in the same direction yung magnetic flux density natin sa area. So meaning so yung flux natin dito will be B. So again, tawagin ko as phi1 times A times cosine of 0 degree. So this is equal to B times A. Okay? Okay ba? So again, so this is our flux. No? So, excuse me, again, so in this case, where the flux density is again, so parallel dun sa perpendicular so dun sa area natin. So again, in the same direction as the normal vector. Okay? So for our case number 2, diba? So let's say ito yung original position, diba? So nung plane natin, nung plane area. Okay? Okay? So tapos again, so ito yung ating magnetic field. Okay? So we have this magnetic field. So note that this is the same magnetic flux density. No? Okay? Nakuha. So parehong magnetic flux density lang to as our original given, diba? So pero again, so this time, so naka-tilt yung area natin. So again, so let's say this is our area. Okay? So again, so ito yung edge na tinutukoy sa problem, diba? So again, so tilted siya dito by an angle of 30 degrees. Okay? Nakuha ba? So ibig sabihin yung normal vector natin, so will be in this direction, diba? So again, this is perpendicular to the area. Okay? So makikita natin sa by geometry, diba? So na this is simply 30 degrees as well. Okay? So kaya area vector natin sa kaya magnetic flux density is now at an area of now at an angle of 30 degrees. So kaya dito yung bago natin magnetic flux so will be given by So again, so this is B, A cosine of 30 degrees. Okay? Okay? So pero again, so what's this BA here? This is the original flux. Okay? So this is Phi1, so then this is cosine of 30. Diba? Kaya pag naka-experience kayo, naka-encounter kayo ng ganitong problem, diba? So again, ang gagawin nyo lang is from the original orientation na perpendicular yung dalawa, pag nag-tilt yung area or nag-tilt yung magnetic flux density, i-multiply nyo lang yung original magnetic flux by the cosine of the angle. Diba? So again, as you can see, diba? So this is the same as the same concept as the cosine law of illumination. Diba? Because remember, yung sa law of illumination natin, so we have the inverse square law. Diba? So yung I over R squared, intensity over R squared. Diba? So pero again, so meron din tayong tinatawag na cosine law of illumination. Yung may naka-multiply na cosine theta. Kasi ganito rin yung nangyayari dyan. Diba? Pag nagtitilt kasi yung area mo, lumiliit yung area kung saan dumadaan yung magnetic flux density natin. So hence, diba? Okay? So nababawasan yung magnetic flux. Okay? So in that case, diba, that's the illumination. No? Okay? So kaya dito, so makikita phi2 is equal to 5 Weber. So then multiply this by cosine of 30. So then you will get this to be 4.3 Webers. Okay? So kaya yung sagot natin dito is letter B. Okay? So any questions sa number 4? No? Okay. Okay. So next number, 5. So itong problem number 5, lumabas na ito noong September 2021, na ulit noong April 2022. No? Okay? So we have Faraday's law states that an induced EMF is proportional to. This is the second statement of Faraday's law. Diba? Yung first statement kasi natin sinasabi na basta mayroong pagbabago sa flux, diba? There will be a change in, there will be a voltage induced. Okay? Tama ba? So again, so yung sinasabi ng Faraday's law, so again, so if you remember, so from lectures, again, this is negative N multiplied by dphi dt. Okay? Tama ba? So again, so the negative sign is due to the Lenz's law. Diba? But as you can see here, so since this is constant, so alam natin yung EMF natin, diba? So it's directly proportional to the rate of change of phi with respect to time t. And what is this phi here? Diba? So itong phi na to is the magnetic flux. Diba? So kaya ibig sabihin, EMF is directly proportional to the rate of change in magnetic flux. Diba? So again, so that's the rate of change of magnetic flux. That's letter C. Okay? So this is letter C. Okay? Okay? So next number 6. No? So ito lumabas noong April 2022. Okay? So a capacitor, so yun ang LC oscillator, so has a maximum potential difference of 15 volts. Okay? So a maximum energy of 360 microjoules. At a certain instant, the energy in the capacitor is 40 microjoules. So at that instant, what's the potential difference across the capacitor? Diba? So in this problem, okay, so in this problem, diba? So again, so this is an LC oscillator. Diba? So ito yung sinasabi ng mga estudyante so na nag-take ng April 2022 na isa sa mga sinabi nila sa akin so na mahirap daw, diba? Sa akin so dun sa board exam. Okay? So although again, so this is just actually pretty simple as long as you know the concepts. Okay? Naka ba? So again, so itatandaan nyo lang dito. So again, this is an LC oscillator. Okay? Naka ba? Kung makikita natin dito sa circuit natin, so we only have an inductor and the capacitor. That's why LC, diba? Sa oscillator. Okay? Naka ba? So and there's no resistor. Okay? Naka ba? So remember, diba? So what does the inductor do? Diba? The inductor stores energy in the magnetic field. Diba? What does the capacitor do? The capacitor stores energy in the electric field. And what does the resistor do? The resistor discharges the energy. Diba? Sa akin, so yung resistor natin, siya yung nagdi-dissipate ng energy. So the fact that there's no resistor here, diba? So means that hindi nagdi-dissipate yung energy natin. Okay? So ibig sabihin, so the energy here is constant. So yun lang itatandaan nyo dito actually. Diba? So ibig sabihin, for example, may charge yung capacitor, walang charge yung inductor, kinonect mo sila in parallel. So then the capacitor will discharge, tapos magcha-charge yung inductor natin. So pag fully charged na yung inductor, so then wala nang charge yung capacitor. Nakuha na lahat ng inductor. So then yung inductor naman yung magdi-discharge. Tapos magcha-charge naman yung capacitor. So okay, so this series of charging and discharging, diba? So again, creates an oscillator na tinatawag. No? Okay? Basta paikot-ikot lang yung energy natin between the inductor and the capacitor. Kaya tatandaan nyo ito yung energy natin, which is equal to the energy stored in the inductor at any given time plus the energy stored in the capacitor at any given time is constant. Okay? Tama ba? Ano ba yung energy sa inductor? 1/2 Li squared. Ano yung energy sa capacitor? 1/2 CV squared, 1/2 Q squared over C, 1/2 Q times V. Diba? Sa akin, so pag pinag-add mo yung dalawang yun, so yung sa inductor sa capacitor, dapat constant lang yung makukuha mo at any given time. Okay? Tama ba? So kasi hindi naman nag-dissipate yung energy. So therefore, conservation of energy lang gagamitin nyo. Okay? Tama ba? Pag naka-encounter kayo ng LC oscillator, so yun yung tatandaan nyo. No? Okay? So dito kasi hindi natin gagamitin yung concept kasi yung problem number 6 nakafocus sa capacitor. Diba? So, okay, so given sa atin yung maximum energy, so nung capacitor natin, so tawagin natin to as WC max. Okay? And again, so we know that the equation here is 1/2 CV squared. So ito yung gagamitin natin kasi voltage yung given sa problem. Walang binanggit tungkol sa charge. Kaya it's better for us to use, diba? So something, diba, kung saan kay voltage lang yung laman, saka something that's constant. Diba? Kasi yung capacitance natin constant to dun sa circuit natin. Nakadepende siya kung anong uri ng capacitor yung ginamit natin. Diba? Okay? So now, so again, since this is a maximum energy and constant tong capacitance natin, so this means that our voltage is also maximum. Kaya may nakalagay dyan, diba, na maximum potential difference across the capacitor. So which is 15 volts. Okay? Tama ba? So okay, we can solve for the capacitance here. Okay? Or actually, pwede tayo mag-gradient proportion. So again, this is for the maximum value. Diba? So then meron sa ating given na isa pang energy. Diba? So again, so which is 40 microjoules. Diba? And so again, so this is at some point in time kung saan hindi fully charged yung capacitor natin. So therefore, by ratio and proportion, so we have that energy divided by the maximum energy should be equal to, so again, this is 1/2 CV squared. So ito yung gusto natin malaman, itong voltage na to, divided by 1/2, so then the C V max squared. Okay? So kaya magka-cancel dito yung 1/2, cancel dito yung C. Diba? Okay? So then, so this will be given by, so again, so yung energy stored, so from the given is 40 microjoules. So again, yung maximum energy daw is 360 microjoules. So that's 360. Okay? So then this is equal to, so again, so we have yung voltage na hinahanap natin. So and the maximum voltage is given as 15 volts. Okay? So this quantity is squared. So then solving for V, so you will get this is 5 volts. Diba? So ay sagot natin dito is letter B. Okay? So any questions? Problem number 6. Huh? Okay? So next, number 7, lumabas noong April 2022. So, so yung tanong lang sa number 7, diba? So is, ano daw yung relation, diba? So nung voltage and current phasor natin. So sa purely resistive material, okay? So yeah, purely resistive circuit, diba? So the current blank, okay? Okay ba? So now, okay, sa akin, so itatandaan natin, pag purely resistive, diba? Sa akin, so the current, okay, so is in phase. So with the voltage phasor, okay? Sa pure capacitor, diba? So the current leads the voltage, diba? So by 1/4. Okay? So by 1/4, diba? So of a cycle. Kasi kung makikita natin sa choices, ito yung nasa choices natin, diba? So for pure inductor, diba? So the current lags the voltage by 1/4 of a cycle. Diba? Kasi nga doon sa libro na pinagkunan ng problem na to, itong tatlong to merong questions. Okay? May questions na ganito. And nung board exam ata, itong pure R saka pure C yung lumabas or pure R saka pure L. So pero basta lang, dalawa din sa tatlong to lumabas sa board exam. Okay? Okay ba? So kaya dapat alam niyo itong mga ganito. So pero naituro naman sa inyo to sa AC circuits. Diba? Okay? So again, so we have pure R. So yung tanong sa problem na to. So therefore, this should be in phase. Diba? So we have letter D. Okay? Next, number 8. Diba? So ito lumabas din noong April 2022. Okay. So we have a coil with a resistance of 60 ohm and impedance of 100 ohm is reactance in ohms is blank. So, okay, so remember, this is a coil. No? So kung coil yan, so ang ibig sabihin this is series RL. Okay, nakaba? Kasi pag sinabing coil, diba? So meron kang resistance, meron kang inductance. So kaya pwede natin i-assume na ito ay series RL. Okay? Nakaba? So kaya kung series to, pwede mong gamitan ng impedance triangle. Okay, so R, X of L, Z. Diba? So then, so by Pythagorean theorem, so then this is given by square root of Z squared minus R squared. Okay, so this will be given by, so we have square root of 100 ohm squared. So then minus, this is 60 ohms. Okay. So this is 60 ohms squared. Okay. So this will be given by, so we have 80 ohms. Okay? So kaya sagot natin dito is 80 ohms. So that's letter C. Diba? Okay? So any questions? Number 8. No? Okay? Number 9. So ito medyo nakakalito itong problem na to, honestly. Diba? So pero kaya, so we will follow the reference here. So kaya lumabas noong April 2022. Okay? So we have an alternating current, diba, with a frequency of 60 Hz is passed through a moving coil galvanometer that measures DC current. Diba? So ibig sabihin, alam natin, yung mine-measure ng galvanometer na to is the average value. Okay? Tama ba? So kaya, yung iba sa inyo siguro yung sinagot dito is letter B. Diba? So yung the average value of the AC current. Pero that's wrong. Okay? Tama ba? Kasi pag sinabi natin average value of the AC current, diba? So this is just 1/2 of the cycle, diba? Yung tinutukoy nating average value na mine-measure ng galvanometer, diba? So is yung average value. So again, so for the whole waveform. Okay, tama ba? So for example, ginamit mo siya for 30 seconds, so then for the whole 30 seconds yung average value na kukunin natin. Okay, tama ba? So again, it is based on definition. So kaya mas tamang sagot dito is yung negligible amount. So bakit negligible amount? Kasi AC to. This is an alternating current, diba? So therefore, if there is an average value, so again, that's a very small value. Okay, tama ba? So again, due to the harmonics, diba? So nung current natin. Okay? Tama ba? So kaya sagot natin dito should be negligible amount. Diba? So not the average value. Okay? Tama ba? So again, so this is negligible. Okay? So this is letter D. No? Okay? So next number, 10. So ito lumabas noong April 2018. Naulit noong April 2022. So again, so nasa handout stop, diba? So kaya nasa solutions natin ito sa Google Drive. Okay? So again, effective resistance of conductors increased by, so again, skin effect sa proximity effect. So again, so naka-explain naman ito sa solutions sa Google Drive. So kaya check nyo na lang doon. So again, so under power system. Okay, this is problem number 1 sa power system. Okay? So next, number 11. So ito lumabas din noong April 2022. Okay? An industrial consumer has a load pattern of 2,000 kilowatts, so and 1,000 kilowatts for 12 hours, diba? So then the load factor is blank, okay? So now, so again, so dito load factor yung given, okay? So and we know for the load factor, so again, this is given by average load divided by maximum demand, diba? Pero since hindi sa atin given yung average load, ika-calculate natin yun. So again, the average load is the total energy produced divided by the period. So ito yung average load, diba? So then, i-divide lang uli natin ang maximum demand. Okay? So again, so kaya meron din tayong ganitong equation sa load factor. For the total energy produced, so sabi dyan, nagde-deliver daw tayo ng 2,000 kilowatts for 12 hours. Diba? Okay, so then plus 1,000 kilowatts, diba? So for another 12 hours. So therefore, this is for a time of, for a period of 24 hours or 1 day, diba? So ito yung tinatawag nating daily load factor. Okay? What's the maximum demand? Ano ba yung demand natin? 2,000 saka 1,000. So therefore, pipiliin lang natin yung mas malaki, which is 2,000 kilowatts. Diba? So then multiply this by 24 hours. Kasi nga daily lang yung given sa atin. Okay? So daily load factor lang. Diba? So kaya pag sinolve natin to, you will get 0.75. Pag naka-percent yung choices, i-multiply nyo lang ng 100. So pero dito kasi hindi naman naka-percent. Diba? Okay? So we have 0.75. Okay? So therefore, this is letter B. Okay? Okay ba? So next, number 12. Okay? So ito lumabas noong May 2008. Okay? So May 2008. So tapos na ulit noong April 2022. Diba? So this is same question as yung nasa handouts natin. So although different problem. Same problem pero different question. Okay? Okay? So doon kasi sa handouts natin, so ang tinatanong is yung secondary impedance. So dito ang hinahanap is the secondary current. Diba? Okay? Okay? So okay, so let's try to solve this one. Okay? So we are given the primary terms, we are given the secondary terms, and we are given the primary current. Hinahanap yung secondary current. Diba? So therefore, turns ratio lang gagamitin natin dito. No? Okay? So remember, the turns ratio is the primary terms divided by the secondary terms. Diba? And again, so remember from lecture natin sa transformers, again, the current ratio IP over IS, so is the reciprocal of the turns ratio. So therefore, this should be IS over IP. Diba? So we have 2,000 turns given a primary terms, 500 yung given a secondary terms. Secondary current yung hinahanap natin. So then primary current is given as 8.66. Diba? So minus J5 amperes. Okay? So kaya pag sinolve nyo to, you should be able to get 34.64 minus J20 amperes. Okay? So kaya yung sagot natin dito, so is letter B. No. So any questions? Number 12. Okay. So sabit lang. No. Okay. So next number 13. So ito lumabas din ng April 2022. No? On which of the following factors does the magnitude of the fault current depend? Diba? So remember sa lecture natin sa power system. Okay? So again, para makalculate natin yung fault current, so ang ginagawa natin is binubuo natin yung circuit ng 0, positive saka negative sequence circuit. So then we solve for the current using the voltage and the impedance. Okay, so kaya dito, so ang kailangan natin is the voltage at the fault point saka yung total impedance up to the fault. So therefore, this is both A and B. No? So this is letter C. No? Number 14. What is the equivalent IEEE device number for a differential protective relay? So again, sa handouts natin ng electrical equipment, kung binasa nyo yun, diba? So again, nandun yung mga device numbers, IEEE device numbers, diba? So for common common devices, okay? Nakaba? So kaya basahin nyo yan, yung mga device function numbers, okay? So again, so yung differential protective relay, that's 87. Okay, so that's letter D. Okay? So actually makikita nyo rin din sa electrical equipments natin na handouts, yung mga lumabas na sa board exam na device function numbers. Diba? So again, nandun sa mga examples doon. So itong number 14, lumabas na to dati, pero ang tanong is, doon is alin sa mga for which of the following has a device function number of 87. So baliktad lang. No? Number 15, so ito lumabas na rin dati. So although this is around 2006 or 2007 pa. So before pa umupo yung mga examiners, diba? So kaya hindi ko na sinama dun sa hindi ko na isasama dito. So kaya lumabas lang ito noong April 2022. Pero kaya lumabas na rin yan dati. So nasa natin yung compilation. So again, so kung nabasa nyo na yung compilation dun sa mga senior ko sa inyo na books, diba? Okay? So again, so this is April 2022. So again, commonly used light sensor in a modern fax machine. So this is the charge coupled device. So this is letter D. No. Okay. Number 16. So again, so ito lumabas na ito noong September 2017. Okay. Naulit noong April 2019. So tapos noong September 2019. So tapos noong April 2022. Okay? Okay ba? So yung tanong sa atin dito so is, which of the following is not a property of magnetic field lines? Okay, so yung tatandaan nyo pagdating sa field lines, magnetic man yan or electric, diba? So they will never cross each other, diba? So hindi never mag-intersect, diba? So again, never mag-intersect yung dalawang field lines. Kasi pag nag-intersect yung dalawang field lines, nag-a-add up yan, diba? So for example, itong dalawang intersection na to, mag-a-add up siya dito sa part na to. Okay? So ibig sabihin, okay? So ito yung lalabas dyan, di ba? So kaya hindi sila mag-intersect. Okay? Naka ba? So ibig sabihin, so mali yung letter D. So kasi this will never cross. No? Okay? So kaya mali sa number 16, di ba, is letter D. So next number, 17. No? So ito lumabas noong September 2017. No? So tapos na ulit noong April 2022. No? Okay? So we have this question. Okay? The terminal voltage of a battery is 11.8 volts. Diba? So nasa lecture to actually. This is circuits part 2. No? So again, so if the battery has an EMF of 15 volts, find the internal resistance of the battery. So let's solve for the internal resistance here. Diba? So again, so remember for a battery, ganito yung circuit natin. Diba? So we have the internal EMF. Okay? So then we have the internal resistance. Diba? So dito yung terminals natin. So okay, we have the EMF. We have the internal resistance. We have the terminal voltage. Diba? So nandito natin kinakapit yung load. Diba? Okay. So that will be the load. Okay? Okay ba? So kaya ibig sabihin, para ma-solve natin yung internal resistance, so then this is given by, so base din sa mga given sa atin, given yung internal EMF sa terminal voltage, ang kulang na lang natin dito is, so let's say yung current na nagpa-pass through dito is I. So then this is divided by the current I. Okay? Pero instead of the current, ang given sa problem is yung power taken by the resistor load. Diba? So therefore, okay? So then yung current natin is just given by, so this is power divided by the terminal voltage. Okay? Nakuha ba? So kaya sagot yung magiging solution natin dito ay 15 volts. Okay. This should be 15 volts, no? Minus 11.8 volts from the given. So then divided by, so again, so we have power is 20 watts, no? So then this is divided by, so we have the voltage again. So again, so the terminal voltage 11.8 volts. Okay? So pag sinolve nyo to, so lalabas sa sagot dito is 1.89 ohm. Okay, sagot natin dito letter B. No. Okay? Number 18. So ito lumabas noong September 2019. So tapos na ulit noong April 2022. No. The question is, which of the following transformer has only one winding? Diba? Okay, so nasa lecture din to ng transformers. Again, this is auto transformer. Diba? Number 19. So ito lumabas noong September 2014. Tapos na ulit noong April 2022. Okay? So again, for a three-phase unbalanced load, the power factor of each phase will be parang yun yung lumalabas sa mga choices natin, diba? So kung i-check natin sa mga choices natin dito, diba? Isa lang diyan sa mga choices natin yung pwede lang sa unbalanced, diba? So kasi yung ibang choices natin diyan pwede rin sa balance. For example, yung letter A, the power factor of each phase will be proportional to the load, diba? So we know power factor is load power divided by apparent power, diba? So kaya ibig sabihin, so power factor is always proportional to the load regardless kung balance or unbalance yung system natin. Okay? Yung letter B, power factor of each phase will be the same. Pwede yan sa balance, pwede yan sa unbalance, di ba? Sa unbalance, di ba, pag power factor are the same, dapat iba-iba yung real power mo, di ba? So again, so then unbalanced na siya. Pero pwede rin na pare-pareho yung power factor. Sa balance naman, laging pare-pareho yung power factor, di ba? Sa letter C, power factor of at least one of the phase must be leading. So remember, sa balance system, pwede kang magkaroon ng tatlong phase na leading. So ibig sabihin, at least one pa rin doon yung leading. So therefore, pwede rin sa balance yung letter C. So kaya ibig sabihin, di ba? So yung pwede lang sa unbalanced, na hindi pwede sa balance dito is yung letter D. Power factor of each phase may be different. So this is letter D. Okay? Next number, 20. So ito lumabas noong April 2022. Meron tayong similar problems sa transformers, di ba? So iba nga lang yung given. 8% yung given doon. So dito 7%. 100 MVA yung bagong base, 7.5 MVA yung original base. The choices are in percent, di ba? So kaya gagamitan lang natin ito ng change of base, di ba? So again, so we have the new base power, old base power. So we have the old base voltage, new base voltage, di ba? So then multiplied by the original per unit impedance, okay? So again, so then this will be given by, so what is S2, okay? So again, so this is 100 megavolt ampere, so from the given, diba? So then the new base power, the original base power is 7.5 megavolt ampere, diba? So and, okay, hindi nagbago yung base voltage, so therefore we can cancel this. Same lang yung gagamitin natin base voltage, diba? So kaya magiging lang itong equal sa 1. So then so the original per unit impedance is 7%. So 7% na yung gamitin ko dito kasi naka-percent naman yung choices. Pag sinolve nyo ito, makukuha nyo yung 93.3%. So this is letter D. Okay? So any questions? Number 20? No? Okay? So any questions so far? Diba? So dun sa pre-board exam nyo. Okay? Okay? So wala kayong questions dyan, diba? So then short break muna tayo. No?